In this video, I will review and illustrate how to solve a problem that is related to safety stock. Anyway, when demand is unusually high during lead time, sometimes we have to dip into safety stock instead of encountering stock out, because when we run out of stock, we experience stock out, and what happens is there will be some costs related to that. We might actually lose customers. Our customers might actually leave and look for a more reliable source of supply. So stock out is in some way unwanted. And so to prevent stock out, entities sometimes carry what we call safety stock. So when the daily demand or the lead time fluctuate and are uncertain. So when the daily demand and lead time fluctuates and are uncertain, the exact amount of inventory that will be used during lead time is also uncertain. Again, when daily demand or the lead time fluctuates and are uncertain, what will happen is the average inventory usage during lead time will also be uncertain. The amount of inventory that will be used during lead time is also uncertain. And the average inventory usage during the lead time needs to be computed, and some safety stock should be added to the average inventory usage during lead time to avoid stock out. So the reorder point with the presence of safety stock is basically the average demand during lead time plus the safety stock. Yeah, again, the reorder point with uncertainty of demand or uncertainty of lead time will need us to calculate safety stock, and the reorder point will need to be added to the average demand during lead time to come up with the estimated reorder point. Okay, so how to determine the correct amount of safety stock? Okay, there are a few factors that needs to be considered here. Two factors: stock out cost and also the holding cost. If you hold, or if we hold too less safety stock, we might actually run out of inventory and stock out cost will occur. Stock out cost includes loss of sales, loss of goodwill, and which may actually have a long-term impact into loss of future sales. While the holding cost is basically when we hold too much safety stock, and we might actually have piles of inventory that will cause us to carry, to have excessive carrying cost or excessive holding cost. Okay, if stock out cost is low but holding cost is high, this is some decision thoughts. Yeah, if holding cost is low while stock out cost is high, then perhaps carrying a large amount of safety stock would be necessary to avoid stock out cost. However, if stock out cost is low but holding cost is high, then maybe carrying a lower amount of safety stock would be preferred instead of because of the carrying cost is too much. Yeah. How do we determine the optimum level? Yeah. How do we determine the optimum level? If demand fluctuates, while lead time is constant, and if both the stock out cost per unit and the holding cost per unit are known, then we could use the payoff table that we have studied in chapter 3. Yeah. But a more general approach can actually be used instead of using payoff table, especially when you have so many possibilities, then having a payoff table using a payoff table will lead to a huge payoff table. So instead of that, we might actually try and determine, a more general approach is try and determine the service level that is desired. Service level meaning what is the level in which we would like to avoid stock out cost. Yeah. So service level is the level where we avoid stock out. So determine the service level that is desired, and then find the safety stock level that would accomplish or would meet the service level that is being aimed for. Okay. So determine the service level. This is the level where we don't experience stock out, and then find the safety stock that will help us accomplish the service level. So the prudent manager will look at the holding cost and the stock out cost to help determine an appropriate service level. So a good manager will think about what are the holding costs, what are the stock out costs to help determine the appropriate service level. A service level indicates what percentage of time that customer demand is being met. In other words, the service level is the percentage of time that stockouts are being avoided. So, service level would be equal to 1 minus probability of stockout. Yeah, and probability of stockout would be equal to 1 minus service level. So let us look at how to determine safety stock with normal distribution. Okay. When demand during lead time is normally distributed, then the reorder point formula will have to be revised from equation 615 to equation 616. So reorder point is equal to the average demand during lead time plus Z multiplied by standard deviation of demand during lead time. Okay. Z is the number of standard deviation for a given service level. This is the standard deviation of demand during the lead time. The amount of safety stock is simply this section here. The amount of safety stock is simply Z multiplied by standard deviation of demand during lead time. I'll give you an example here. Hinsdale Company carries a variety of electronic inventory items, and these are typically identified by SKU. In particular, SKU A3378 has a demand that is normally distributed during lead time with a mean of 350 units and a standard deviation of 10. Hinsdale wants to follow a policy that results in stockouts occurring only 5%. So if this is the probability of stockout, then the probability then the service level is 1 minus 5%, meaning we are looking at the service level of 95%. So in figure 6.8, we can plot this. 5%, this is a normal distribution. The total area is 100%. 5% would be the stockout area, probability of stockout, and this area here, the entire unshaded area, is 95%. So the mean during lead time is 350. Standard deviation of demand during lead time is 10. Okay, we need to find the safety stock, and using this formula here, safety stock is Z minus the standard deviation of demand during lead time. So we need to find what is Z. What we need to do is we need to go to Appendix A, go to Appendix A, which is Appendix A is basically the normal distribution table. We go to Appendix A. Okay, Appendix A. Now we need to look for 95% in the table. So you look for 95%. We don't have an exact cell with 95%, but we need to find the one that is closest. Yeah, that is the closest. And I think this is the closest, this one here. Yeah, that's the closest, 95%. This is closer to 95% compared to this. And this falls into a Z of 1.65. The C is 1.6. So the C is 1.65. Now let's go back to the formula. If Z is 1.65, our average demand during lead time is 350, and our Z is 1.65. Our standard deviation during lead time is 10, and that gives us a safety stock of 16.5. So this is the average demand during lead time plus safety stock. So the reorder point is 367. That consists of average demand during lead time and the safety stock. Okay. There are three situations in which we lead to three different formulas. When the demand is variable or uncertain, but the lead time is constant, this is the formula. Then we use average demand because demand is variable, sometimes high, sometimes low. So what we do is we use average demand multiplied by the lead time plus Z multiplied by standard deviation during standard deviation of demand during lead time multiplied by the square root of L. When the demand is constant, so the demand is constant, but the lead time varies. Sometimes high, sometimes takes longer, sometimes shorter. Then our formula is going to be the demand, which is constant, multiplied by average lead time, plus Z multiplied by the demand during lead time multiplied by standard deviation during lead time, demand during lead time. Third is when both demand and the lead time are variable, and this is the most usual. When both demand and lead time are variable, then we use this formula. We use the standard average demand multiplied by average lead time plus Z multiplied by square root of average lead time multiplied by standard deviation of demand during lead time squared plus average demand squared multiplied by standard deviation of demand during lead time squared. There you go. We've got three formulas for three different variations. The next section are examples where we can apply each of those formula, but I will continue this in a short while. Okay, let me continue. So we will look at three examples in which these three conditions have to be used. So first one is Hinsdale has decided to determine the safety stock and reorder point for three other items, F5402, B7319, and 59004. For 5402, the daily demand is normally distributed with a mean of 15 units and a standard deviation of 3. The lead time is exactly 4 days. So here we see lead time is constant. It's exactly 4 days, but the daily demand fluctuates, is variable, and it's normally distributed with a mean of 15 units and a standard deviation of 3. So which of these three formulas are we going to use? It said demand is variable, lead time is constant. So I think SQ502, we need to use the first formula, formula 617. So average demand is 15 units. Okay, standard deviation is 3, lead time is 4. Yeah, so average demand is, let me go back again. Average demand is 15 units. Lead time is 3 days. Is it? Oh, sorry, lead time is 4 days. Standard deviation is 3. So 15, lead time is 4 days, plus Z multiplied by standard deviation, which is 3, multiplied by square root of 4 exactly times. Okay. And it said here, Hinsdale wants to maintain a 97% service level. So we go to table 8 to find the Z value for 97%. Okay. Okay. We look for 97%. 97.062 and 96.995. This is, looks like this is closer to 97%. So that's going to be 1.88, either 1.88 or 1.89. Okay, the book shows that the Z value for 97% is 1.88. So now we can plug that into the formula. Average demand 15, lead time is 4 days. 15 multiplied by 4 plus 1.88 multiplied by 3, that's the standard deviation. That's the deviation of demand. 3 multiplied by square root of 2. And we get a reorder point of 71.28. That's broken down into 2. 60, that is the average demand during lead time. Yeah, average demand multiplied by lead time in days, so 60 plus the safety stock, which is 11.28, totaling to a reorder point of 71.28. Okay, the next formula, the next case is for B7319. In this case, the daily demand is constant and at 25 units per day. The daily demand is 25 units per day. The lead time is normally distributed, meaning it varies. And through history, they were able to determine that the mean of lead time is 6 days and the standard deviation of lead time is 3. Hinsdale wants to maintain a 98% service level on this product. So demand is constant, lead time is variable, so we use this formula. So the demand for B7319 is 25 units per day. The average lead time is 6 days, and the standard deviation is 3. They want to maintain 98% service level. So we go again to table A, which is normal distribution table in Appendix A. We look for 98%. 98% is somewhere, is here. This is 98%. It's closer to 98%, I think. So that is 2.05. Z 2.05. Okay, so then we plug those information into the formula. Yeah. The demand is 25. The average lead time is 6 days. This one here, yeah. Daily demand is 25. Average lead time is 6 days. Standard deviation is 3. Yeah, 25 multiplied by 6 plus a Z of 2.05 for 98% service level multiplied by standard deviation during lead time, which is 3, multiplied by the demand during lead time, daily demand, which is 25. So we get 150, that is the average demand during lead time. And this is the safety stock. Yeah, Z 2.05 multiplied by 3 multiplied by 25. So the safety stock is 153.75. So the reorder point is when the inventory level hits 303.75 or 304. When it hits this level, the entity needs to immediately make an order. This is the average usage during the lead time, 6 days, but there are safety stock. Why do we need safety stocks? Because the lead time fluctuates. Sometimes it takes longer, sometimes it's shorter. Okay, now let's look at the third product, which is F9004. The story with F9004 is that the daily demand is normally distributed, meaning the daily demand varies, fluctuates with a mean of 20 units and a standard deviation of 4. And the lead time is normally distributed. Also, the lead time fluctuates with a mean of 5 days and a standard deviation of 2. Hinsdale wants to maintain a 94% service level. So we go to Appendix A, look at normal distribution table. Hinsdale wants to maintain a 94% service level. We look for 94%, and that falls, I think, here. Yeah, this is closer to 94%, I think. Yeah, we will need to confirm that. So this is 1.55. Okay, we go back here. Yeah, for 94%, the Z is 1.55. Okay, now, because both demand and lead time are variable, they fluctuate, we gotta use this formula. Okay, average demand multiplied by average daily demand multiplied by average lead time plus Z multiplied by square root of average lead time multiplied by standard deviation of demand square plus daily demand average square multiplied by standard deviation of lead time square. Okay, so we have the formula. We plug in the data. Yeah, average demand during lead time is 150. Where is that? Average demand is, sorry, no. Daily demand is normally distributed with a mean of 20 units. So average demand is 20, and average lead time with a mean of 5 days. So 20 multiplied by 5 plus the Z is 1.55 multiplied by square root of average lead time multiplied by standard deviation of daily demand squared. So multiplied by square root of average lead time, which is 5, multiplied by standard deviation of daily demand, which is 4 squared, plus average daily demand square multiplied by standard deviation of lead time square. So average daily demand, which is 20, yeah, 20 squared multiplied by standard deviation of lead time, which is 2 squared. So what we get is 100 average demand during lead time, 20 by 5. And we get the second component, which is the safety stock from this expression here, 63.55. So the reorder point is, we get a reorder when the inventory level hits 163.53. Okay, so those are the three scenarios, different situation. We got to use different formula for that. How to calculate annual holding costs with safety stock? When we have this situation here, yeah, when we have this situation here, this is the average inventory during lead time, and this is the safety stock. So when we have safety stock in hand, Yeah, when we have safety stock in hand, remember, when we calculate average, when we calculate annual holding cost, we multiply the average inventory level during the year multiplied by the carrying cost. And the average inventory during the year is EOQ divided by 2. EOQ divided by 2, this is the average inventory during the year, and we multiply that by the carrying cost. That is our carrying cost for our average inventory during the year. But when we have safety stock, we do not add the safety stock into the average inventory. We add safety stock to this. So the formula becomes the average inventory during the year, Q divided by 2, or EOQ divided by 2, multiplied by carrying cost plus the safety stock multiplied by carrying cost or holding cost to get our total annual holding cost. So this is the total annual holding cost when safety stock is present. Okay, let me show you how we can use POMQM to calculate reorder point. Okay, so I'm going to click new. I will click new here, and here I have an option. Let's use reorder point of safety stock with normal distribution. Okay, so reorder point with safety stock, normal distribution. I will click OK. All right, then here are some of the questions that I need to answer. Let me minimize this table or rearrange this table, and let me use the example that we had. Let me use the 3 examples that we had. We will use the example for SKU F5402. The daily demand is normally distributed with a mean of 15. So daily demand is normally distributed. Here it said daily demand D bar. This is D bar. That means this is the average daily demand. It said here daily demand is normally distributed with a mean of 15 units. So, okay, 15 units. And the daily demand has a standard deviation of 3. So daily demand standard deviation, this is 3. And we wanted a service level of 97%. So we type in 97. The lead time in days, these are exactly 4 days. So we type 4. Okay, and because this is lead time is constant, we have no standard deviation for lead time. We leave it empty. And after that, we click solve, and we find that the Z value is 1.88, which is correct. Expected demand during lead time is 60. Yeah, 15 by 4. Yeah, 15 by 4 is 60. Safety stock is 11.28. Yeah, which is 1.88 multiplied by that expression there. And so the reorder point is 71.28. So this is how we solve for the first situation where daily demand varies and lead time is constant. Okay, the second situation is when daily demand is fixed. Okay, daily demand is fixed, but lead time is variable. Okay, so we will edit our data. Yeah, we will simply edit our data. Here, the daily demand. Let's look at the problem here. For BKU, so for B7319, the daily demand is constant at 25. So this one is 25. Because it's constant, it does not have any standard deviation. So there's no standard deviation for demand. The service level wanted is 98%, so we type in 98. And the lead time varies with a mean of 6 days, so the lead time is 6 days, with a standard deviation of 3 days. There you go. See how the difference is, yeah? Once we've done that, we click solve, and we find that the Z value is 2.05, which is correct. Yeah, the expected demand during lead time is 150. Yes, it's 150. Yeah, demand constant, which is 25 multiplied by average lead time of 6, that gives us 150. And a safety stock of 153.75, which is that, for a reorder point of 303.75. So when the unit falls to 304, they have to immediately put an order. They have to immediately send out an order find the Q. You have to calculate the EOQ. You put in an order by the amount of economic order quantity. Okay, let's look at the third one, where the third situation where SKUF9004, where the daily demand varies and the lead time demand varies. So we gotta go to, I'm gonna click new, and then I will choose reorder point. Actually, reorder point with normal distribution still here, yeah. Inventory, reorder point, no, cancel. So reorder point with normal distribution. So what it said is daily demand is normally distributed with a mean of 20, okay, mean of 20. A standard deviation of demand is 4, and the service level wanted is 94%, so we type in 94. The lead time in days, it also varies with the normal distribution with a mean of 5 days. So average lead time is 5 days, and the standard deviation for the lead time is 2 days. Okay, 2 days, and then we click solve, and we get a Z value of 5. Where is that? Yeah, Z value of 1.55. There you go. Our expected demand during lead time is 100. Our safety stock is 63.53, and our reorder point is 163.53. So that is when we have reorder, we have safety stock with normal distribution. The second part of safety stock is when we have discrete distribution. This is a situation when the inventory does not arrive simultaneously, meaning the inventory arrive a little bit at a time. Okay, and we have to make a decision how much additional order do we put to maximize value. So I will discuss about that in another video to keep this video short.